Alright, hi guys, let's go ahead and get into 2.9 logarithmic expressions. And so I'm going to start reading this out to you. Every operation has exactly one inverse operation. We learn inverse operations because they will allow us to solve equations involving various operations. So if we're ever encountering something that requires us to solve for x, where we want to subtract 3 in this case, knowing the inverse of addition will help us do that. Right, so the inverse operation is subtraction when it comes to addition. Multiplication we know to be division, and then cubing we just take the specific root in relation to whatever particular power we have. So in this case we'll say cube root. Right? Then exponentiation, the x inverse operation for this is logarithms. Okay, I'll be honest, it doesn't really feel natural at first as far as why this works, but in time it will work out. Okay. And so the big idea here is just as we can write rational numbers in decimal form and fraction form, we can also write equations in exponential form or logarithmic form. These forms create equivalent statements that represent the same claim. We're not changing the problem at all. When we convert back and forth, we are simply rewriting the equation in equivalent form. So basically, we can write exponentials in logs, and exponentials, right? They mean the same thing, just written differently. Now, they can be inverses of each other. The actual function type it is are inverses of each other, but as far as converting, we can make one form the other to be the same. The same way when we think about 1/2, that's 1 divided by 2. The same thing as, like dividing by 2 is the same thing as multiplying by 1/2, right? So they're equivalent expressions of the same thing. So let's go ahead and convert the following equations from exponential form to logarithmic form. I pretty much call it the circle of life. So right now we're starting off as exponential, and I'm going to rewrite this as log form. So I start off here. So the base of my original exponential will now become the base of my log. So log base 3 of 9. So that's how my arrow is interpreted. So I start here, my base, log base 3 of 9. And so 9 is the input of this log. Now typically you won't see me put parentheses very often, but it's assumed that there are parentheses here to define that 9 is the only input of this log. And then we'll go across the equal signs again to be all equals to 2. We've rewritten the exponential into logarithmic form. So let's keep doing this for the rest of the problems. Here I have log base 10 of y is all equals to the exponent x. Here I have log base r of w is all equals to the exponent t. Here, this time, we're going from the right hand side to the left hand side. If you feel more comfortable to perform this step, where you do it on the same side each time, you can rewrite it real quick and do it that way, right? You could go the same way. Log base e of y is equals to 3x. And then recall that log base e can also be rewritten a little bit more concisely as natural log of y is equals to 3x, right? This notation here is the same thing as ln, this natural log. Alright, now that we know how to convert, I also would like to go back to a base factor as far as notation-wise. If the base of a log expression is 10, this is called the common log, and it's written without a base. For example, log of 3, it's understood to have a base of 10. So log 3 is the same thing as log base 10 of 3, right? It's assumed that we're saying that the base is 10. Alright, let's continue. Example number 2, convert the following equation from log back to exponential. So we're pretty much just doing the circle of life but backwards this time. So the base of the log will now become the base of my exponential. So 7 to the power of 2 is all equals to x. And knowing this now, this helps us refine and solve for what x is. We know for a fact that x will be equals to 49. This one, let's go ahead and convert it from right to left. So log base 3 of x is equals to y. Here, I can't quite solve it any more than that, so we'll leave it as is. Here, I know that the base here is assumed to be 10, right, since it's not written to me. I'll say 10 to the power of 2 is all equals to y. So y is equals to 100. Here, again, recall that the natural log is essentially log base e. Although you don't need to rewrite it, maybe just have a mental note that yes, the base here is e for this particular log. So I'll say e to the power of 4 is all equals to c. Boom. Now that we know how to convert logs and from exponentials to logs to exponentials, we're in a really good spot now. Let's move on. We're going to use those skills now to help us evaluate these without a calculator. It's hard to kind of think about what is log base 2 of 8. A better way to think about it is just by converting it back to an exponential. So I'll say it's all equals to something. I don't know yet. So we're trying to figure that out. So I'll say 2 to what power is equals to 8. So let's do that again. So 2 to what power? 2 to what power is equals to 8. Right? We're just converting back to exponential, and this is the form that we'll come up with. And I can start to think about what values I can put in for this question mark. And I believe the question mark should be equals to 3, because 2 cubed is equals to 8. So now I know what it's equals to. That means I know what the log should be equals to. Right? So this question mark is no longer a question mark. I'll now say that the log base 2 of 8 is equals to 3. Alright, let's go to part B. We're going to think about 5 to what power? 5 to what power is equals to 25. This was a little bit more easier to think about. I think 5 squared is equals to 25. Now that I know that, I can say log base 5 of 25 is equals to 2. Here's part C. 2 to what power gives me 32. I believe 2 to the power of 5 gives me 32. So that means log base 2 of 32 is 5. Let's keep going. Here I have log base 10 of 100. 10 to what power gives me 100. 10 to what power gives me 100. I believe 10 squared gives me 100. So log of 100 is equals to 2. Now I have 16 to what power is equals to 4. In this case, since we're getting smaller, I'm thinking of a fractional exponent to represent a root. I believe 16 to the power of 1/2 is equals to 4. Recall that the power of 1/2 is the same thing as the square root of 16 here, which makes this statement true. So I can see that the question mark is equals to 1/2. Alright, here's part F. 3 to what power gives me 1. 3 to what power gives me 1. This means anything to the power of 0 gives you 1. So I know that the question mark here is 0. So log base 3 of 1 is 0. I'll be honest, anytime you see 1 as your input of a log, it's always going to be equals to 0. Alright, log base 10 of 10. So 10 to what power gives me 10? In this case, 10 to the power of 1 gives me 10. So the question mark here is simply just 1. Here's H. 6 to what power gives me 1 over 36. 6 to what power gives me 1 over 36. And here I'll have to be creative. Since I see that this becomes a fraction, I more than likely had to have a negative exponent to create the negative reciprocal. So I think if I take 6 to the power of negative 2, that is equals to 1 over 36, because this can be rewritten as 1 over 6 squared, which so happens to be equals to 1 over 36. So log base 6 of 1 over 36 is negative 2. Alright, and then we have all these properties of logs, which I'll cover now, which we kind of somewhat seen here already, but we'll deliberately talk about them here. If log base b of 1, right, so if your input is 1, we know for a fact that this will be equals to 0. Log base b of b, so if the base of your log and the base of your input's the same, and the result is simply technically your exponent. And we have an exponent here of 1, so this all equals to 1. Here, same thing. Now that I know that it's not 1, log base b of b to the power of x, the result is simply just x. Here, if you have a base raised to a power of a log with the same base, then the result is simply the input of the log. So I'll say that again. If you have some base raised to a power of a log with the same base, then the answer is simply your input. Alright, let's continue. Log base b of x to the power of m. This is called our power rule. I can rewrite this, bringing this power in front of the log. I can say m log base b of x. That is an equivalent statement here. So I can pull this out of the input, of the power of my input in front. Here, if I'm multiplying two things in my input, I can separate them into their own individual logs. Log base b of m plus log base b of n. If I'm dividing two numbers in my input, I can separate them here in their own individual logs where they're going to be subtracting this time. So log base b of m minus log base b of n. And then one last one, log base m of n. This is going to be our change of base formula. I would put a star by this one. I can rewrite this into a different base if I'd like to. Let's say if we want to convert it back to base 10, I would write this as log base 10 of n divided by log base 10 of m. And to be honest, let's generalize this base to be anything I want it to be. Let's just say that the m, or let's just label this as x perhaps. Right? You could do any base you'd like, as long as you take your input, log base of the input, divided by log base of the base. All right. So those are all our properties of logs. We'll be using them kind of throughout the last few examples here, and then we'll be done with 2.9. So I notice here I have things dividing inside my input, so I can separate them into log base 2 of 1, all minus, log base 2 of the square root of 2. Now, of course, I don't really need to include these parentheses here, but I'm going to keep doing it just to indicate the input. And here I can go a little bit further and rewrite log base 2 of 1 to be equals to 0. We know that from my earlier property. And then here I can also go one step more. It might be more clear to rewrite this as log base 2 of 2 to the 1/2. Notice now the base of the log and the base of the input are exactly the same. The answer will simply be the exponent. So 0 goes away, then I have negative 1/2. Right? This component here, base the log, is the same as the base of my input. They cancel and give me the exponent of 1/2. And so negative 1/2 is the final answer here for part A. So we use two properties there. Or really a mix of three. Alright, here's part B. Let's rewrite this as log base 10 of 100 to the power of 1 over 5. And then I can rewrite that as 1/5 log base 10 of 100. And I really want to signify the 10 here, because then I can simplify this particular log by thinking about 10 to what power. Right? 10 to what power gives me 100. So log base 10 of 100 is simply equal to 2. So basically I do some scratch work on the side to figure out what this is. And so I'm just kind of converting on the side. 10 to what power gives me 100? 10 squared. So that's how I got to 2 here. And then 1/2 times 2 is equals to 1. Here's part C. This might be easier to see if we convert this decimal into a fraction. So I might say log base 5 of 1 over 5. And that can also be further rewritten as log base 5 of 5 to the power of negative 1. Now that the base of the log, the base of the input are the same, the result is simply the exponent, negative 1. Alright, here's part D. This requires maybe a little bit of creativity. Let me think. Well, maybe not so much. Since these logs are multiplying, I can also put them back into one log where the inputs are multiplying with each other. Or sorry, the fact that these logs are adding, I can take the inputs inside of one log where they're multiplying. So log base 6 of 9 times 4 is equal to log base 6 of 36. And 6 to what power gives me 36? Well, that's 2. Here's E. Let's see what we can do here. I think I can apply the power rule and bring this back in as a power. So log base 7 of 2, sorry, 2 squared minus log base 7 of 196. 2 squared is, of course, 4. And now that these two logs are subtracting, I can rewrite them as one log where their inputs are dividing. So 4 over 196. And personally for me, I don't know what that is. I think it does simplify pretty nicely here. Let's bring up my calculator. Since I don't really know at the top of my head, let's use this instead. Let's do, hello. Alright. 4 divided by 196. Convert that back to a fraction. Nice. So I get log base 7 of 1 over 49. That could be further rewritten as log base 7 of 7 to the negative 1. Or sorry, 7 to the negative 2. Now my base of log, the base of the input are the same. It gives me the exponent. Negative 2 is the final answer here for part E. So that wraps up 2.9. Hope you guys have a good day.